All UPS topologies deliver consistent and correct voltage to the load, but the differences in how they do it are how we get the different topologies. The first topology that we're going to discuss today is offline UPS or standby UPS. This kind of UPS takes utility power and transfers it straight through to the load. This allows a few anomalies to get through, but when the voltage gets down low enough that the IT load can no longer be supported on its own, it relies on its battery to provide power to the load. The second type of topology, and the next step up, is a line interactive UPS. Line interactive, like the offline UPS, lets a few power anomalies through. However, it employs a buck boost transformer to manipulate the voltage into a tighter tolerance for more sensitive loads, while also preventing the battery from being used as often. This extends the battery life and decreases the cost to maintain this UPS over its lifetime. The final topology we'll talk about today is the online UPS. An online UPS consistently conditions power from the input of the UPS to the output by converting AC power to DC stored power and then back to AC power to support your load. This completely isolates your IT load from any power anomalies that might come down from utility and is the best choice for your most sensitive IT equipment. To better explain the differences in UPS topologies, let me demonstrate by using these lamps to simulate the output of each UPS. Each UPS is plugged into this variac, which is going to simulate the input or utility power. As I manipulate the variac, the voltage will go down or spike slightly up, affecting the input voltage to the UPSs. The lamps will be the load and show you what the UPS load would actually see. As we lower the voltage coming into these UPSs, you'll see that the offline and line interactive UPS loads actually dim. This is because they're not conditioning the power fully. As we drop low enough, the line interactive should click over to its buck boost transformer, raising the voltage enough to keep it into a tighter tolerance for the IT load. You'll notice that both of these are dimmer than the online UPS. As we lower voltage slightly more, the offline UPS does the only trick it knows, which is switch to battery. You'll hear the alarm go off, signaling that it's now on battery and it's no longer using utility power to support the load. We'll continue to lower the voltage, and we'll finally see that the line interactive UPS will click to battery. This is a wider input voltage range that allows the line interactive UPS to not use battery as often, therefore decreasing the maintenance and battery change costs through the life of this UPS. As we continue to lower the voltage to 80 volts, 75, 70, 65, and finally 60 volts, you'll see that the online UPS never fluctuated the consistent power it was supplying to the load. This is because it is converting AC power to DC power and back to AC power consistently, isolating this lamp from any anomalies the utility power would show. Beyond what we've discussed here today, there may be other considerations you have to take when choosing the correct UPS for your application.